All right, guys. So today, yesterday we looked at just how to simplify a radical, right? You were just given one radical, you had to go ahead and try to simplify. Today we're going to look at multiplying. We're going to look at dividing, which we've done all of this when we had just regular radicals, not cubed roots, fourth roots, and all that stuff. But then we're also going to look at rationalizing the denominator. So really the biggest, this isn't bad, the multiplying, dividing, because that kind of takes it right back to what we learned yesterday. The part that gets confusing is the rationalizing. Because before, when we rationalized, if there was a radical 3 on the bottom, we multiplied top and bottom by radical 3 and we were good. We didn't have to do much thought to it. But rationalizing with cubed roots, fourth roots, fifth roots, that kind of stuff, it takes a little more thought. Okay, so that's probably where we'll spend a lot of time today. But let's start with multiplying and dividing. We'll do multiply first. So it's just like when we multiplied radicals before. If you have something set up where you have two radicals separate, let's multiply them together, and then we'll kind of break it down and see where we can go from there. So number one, just regular square roots. So that's stuff we've seen before. So again, you want to have a calculator out in front of you. Make sure we're using those buttons appropriately. All right, so number one, radical 27 times radical 3. Let's go ahead and multiply them first. So what is radical 27 times radical 3? Radical what? Radical 81. Is that perfect? Yeah, square root of 81 is 9. So when you're looking at a problem that's multiplication with radicals, multiply them first, okay, and then try to simplify things. All right, so number two, cubed root of 9 times the cubed root of 81. Let's multiply them first. What do we get? Okay, so we get the cubed root of 729. And then is that a perfect, pretty one? Can you do the cubed root of 729? What do you get? 9. All right, number three, fourth root of 8 times the fourth root of 32. So again, multiply them first. 256. Okay, so we get the fourth root of 256. And then, is that perfect? It is 4. So sometimes when you're working through these, you have two roots where to start with they weren't something pretty that you could work with. Once you multiply them, it turns into something perfect. It's a lot easier to simplify. What about number 4? Radical 6 times the cubed root of 12. Why can't I do that? Right. You're absolutely correct. I can't actually multiply these. Because when we multiply, we kind of put them underneath the same radical, right? The radicals have to match. They're the same. So if one's a square root and one's a cubed root, there's nothing I can do. That's it. I can't do anything else. So something like this, I can't simplify. There's nothing I can do with that. So make sure your radicals match when you're trying to put stuff together. So every once in a while, I might throw one in there like that they don't match. Don't just get in the habit of blindly doing it, okay? Make sure you look at it. All right, but you know as well as I do, not everything works out that pretty and perfect, right? All right, so number 5, fourth root 7x to the 6th times the fourth root of 32x squared. So again, it's a multiplication. Let's multiply it first. So we're going to get the fourth root of, what's 7 times 32? 224? Yes, x to the 6th times x squared is x to the 8th. You add your exponents when you multiply. That's x to the 8th. Okay, so again, we want to multiply them together first, and then see if we can simplify. Fourth root of 224 is not perfect. So if it's not perfect, what do I have to do? Yeah, the factor tree. So let's do your factor tree on 224. What? 1 and 12? You want to try again? 224 divided by 2 is 12. 112. You didn't say the 100 on there. I'm like, wow, Peyton, you're not even like registering that, right? All right, 2 and 112 is that's good. That's good. So what is that? 2 and 56. 2 and 28, 2 and 14, 2 and I was that annoying person who did everything by twos. I know that drives some of you crazy. All right, how many 2's does it take to come out? It takes 4 of them, right? The index is 4, so it needs 4 of them. 1, 2, 3, 4. So what comes out then? 1, 2. It takes 4 of them in order to actually come out of that. What do you do with the leftover stuff? You put it back in. So I'm going to have this 4th root of, what number goes under there? 14. Good, you get a 2 and a 7 left over. All right, and then we also had an x to the 8th. What do we do? How do we simplify this from yesterday? Yeah, and remember it was 8 divided by 4 is 2, so x squared. Yeah, everything we learned yesterday kind of comes back into this. Once we multiply them together, then it's just like what we did yesterday. So those of you that were not here yesterday, you get a crash course. Yesterday would have started here. All right, number 6. There's some extra stuff going on out there. What do I do with that stuff not under the radical? Yeah, multiply them. So I have the 2 times the 3, 6, which is on the outside. And then we're going to have the cubed root. Then we'll multiply the numbers. 6 times 9, 54. What's x to the 4th times x to the 5th? Good. X to the 9th. Good. And y cubed. All right, so first step is just to multiply those together. All right, cubed root of 54. Is it perfect? Nope. All right, well, let's go ahead and break that down to your factor tree. We'll see kind of what pairs we got going on in here. Or not pairs, but how many does it take to make a group here? Good. So when you do your factor tree, it takes groups of 3 in order for it to come out. So 1, 2, 3. So the 3 comes out. Yes. I'm going to have to multiply that by that 6 that's out there. So we actually get 18. All right, and then I had that single 2. He needs to go back in. Good. 9 divided by 3 is 3. 3 divided by 3 is 1. Oh, that's a really long radical. Talk to me if I lost you. Ramon? When you're looking at this, like my x to the 9th, I takes, okay, just in case anyone else doesn't, x to the 9th means I have 9 of them. So I need the groups of 3. There's 1, 2, 3 groups that came out, and there's nobody left over. So nobody has to stay back inside. It's x to the 9th right here. There's only y cubed, so that means I have 3 of them. I need groups of 3. I have one group of 3 that comes out, and there's nobody left to go in. Talking about this? Oh. Okay, all right. Does that make sense now? Okay. Oh, gotcha. Gotcha. All right. Other questions here? All right. Number 7. Oh, we get some big numbers in there. But notice we're just looking at regular old radical here. It's just a square root. Just 2400. X to the, good. What is my index? 2. It's just a regular square root, right? You'd say that's a square root of something. If you square something, what number do you take it to? 2. You don't have, excuse me, you don't have to write it in, but you have to recognize that's what it is. So otherwise, when you go to do factor trees and all that, you won't know how many needs to be in a group. All right, square root of 2400. Is it pretty? Nope. Okay, so we need to break that down. Whew. Good. Groups of 2, because we're doing square root. So group of 2, group of 2, we have group of 5. Okay. This is back to what we've done in the past, right? Looking for groups of 2, they come out. So 2 times 2 is 4, times 5 is 20. And then left over, give me 6. That goes back to beginning of the semester right there. All right, but then we got the variables in there, which we've not looked at before. So for x to the 7th, you're going to have 3 groups that would be out, and how many would stay in? 1. And again, for those of you who aren't sure, that means I have 7 of those. You're looking for groups of 2. There's 1, 2. I have 3 groups. That's where this came from. And there was still 1 left that's not in a group. He goes back in. Good. You'd have 3 groups of y. Y to the 3rd. And again, 6 divided by 2 is 3, so we can do that one pretty easy. How we doing? Lovely. Ramona's lovely. Do you guys want to try the next one on your own? Okay. All right, guys. First thing, we want to multiply them. So the 4 is out front. Cubed root, 2 times 12. X squared, x to the 4th. Y squared, y 5th. All right, so there should have been step 1. Just want to multiply it all together. All right, from there, cubed root of 24, perfect? No, so we have to do factor tree. Doesn't matter, we all end up in the same spot. All right, so how many do I need in a group to come out then? I need 3. So 1, 2, 3. So a 2 comes out, but there's already a 4 out here. So it'll become 8. Cubed root. We have a single 3 then that's going to come back under. And then my x's, 6 divided by 3 is 2, so x squared. And then here, again, 1, 2, 3, 4, 5, 6, 7. I need groups of 3. So I have 2 groups of 3, y squared. And then there's another y that's left over. So 8x squared, y squared. Cubed root, make sure you get that little 3 in there, of 3y. Oh, forgot that little thing. You will lose a point every single time you forget that index. All right. Yeah, we're still on multiplying and simplifying. We'll make sure we got this down because it shows up more often than probably just about anything else. All right, so again, multiply them first. So we have the negative 2. All right, guys, what's 9 times 18? 162? You're right over there, Michaela? All right. And then we get x to the 9th, good. And y to the 12th. All right. So first step, multiply it all together. All right, 4th root of 162. Is it pretty? Of course not. All right, so we'll go ahead and break it apart. Go 9 and 18. How many do I need in a group to come out? 4. 1, 2, 3, 4. So what happens to that 3 when it comes out? Yeah, it multiplies by that negative 2. So we get negative 6. And then the 4th root of 2. Don't forget that little 4 there. If you just say radical 2, that means square root. So you got to be careful. All right. right, your x's then, you have x to the 9th. How many groups of 4 can I get out of that? 2. How many would be left? And then I can get 3 groups out of my y's. Anybody left in my y's? No. And then, what? Okay. Yeah, I do that sometimes too. Then I have to go back and erase because it bothers me. Too big of a space. That's better than not enough space and you're like trying to squeeze it in there. I would rather the radical be too long than too short, because then it's wrong if it's too short. Smart. All right, let's take a look at number 10. Oh, those numbers are big. It's all right. Numbers outside. 6 times 3? 18. And then we're going to have the 5th root. 10 times 160. 1600. And then x to the 7th. Good. Remember, there is an x there, so it's x to the 1st. Good. Whew. I even put it together and it's still long. All right. 5th root of 1600. Pretty? Probably not. I mean, I always check them. You never know. I'd hate for you to do this huge factor tree and be like, oh, this is perfect. What was 200? Don't divide it by 5. 5th root. Did she show you how to do 5th root? All right, so let's do the factor tree on 1600. I'll do mine, you guys do yours. All right. Oh, so how many does it take in a group? 5. Do I have 5? 1, 2, 3, 4, 5. So what do I do with that 2 when it comes out? Good. 2 times 18 is 36. And then we're going to have the 5th root. What goes back underneath there? Not just 5 and 2, but another 5. Yeah. So 5 times 5 is times 2, 50. All right, so that takes care of our number. And then my x's, how many groups of 5 can I get out of this? Just 1. How many are left over? 2. My y's, how many groups of 5? 1. How many left over? My z's, how many groups of 5? How many left over? So 36 x, y, z, 5th root of 50 x squared y. Yes. Remember the index. Oh, well, of course it does. That'll do it. All right, any questions on multiplying before we move on to dividing? Okay. Dividing, what's going to happen here is I'm going to see the same mistakes I saw from you guys when we did regular radicals. You try to rationalize before you've actually simplified. You guys did it all the time before. I can see it happening again. But guys, I cannot stress to you enough. Simplify first. Important, right? All caps, underlined it a whole bunch of times. Highlighter, bold, whatever. Fireworks. Okay, simplify first, guys. Otherwise, your problems are going to get ugly, like bad, bad. Some of you guys did it the hard way before, and it wasn't too bad with the radicals, but with this stuff, it's going to get real ugly. So you want to simplify first. Now, as long as the radicals match, notice this one's written with 2 separate radicals, one on top, one on bottom. This one's written with just a giant radical. Do you remember what we always did first with them? We always split those radicals, right? So there's one on top, one on bottom. All right, so we're allowed to do them either way, right? They mean the same thing. So you want to simplify. If they're both under a radical, then that means we can simplify this stuff. So what is 189 divided by 7? 27. Now, have I actually used the cubed root of anything yet? No, so that is still there. So cubed root, you said 27? And then I have x to the 7th on top and x squared on the bottom. It's going to be x to the 5th. All right, that goes back to the last chapter that we did, like canceling out, right? Take that out. That one turns it into a 5. Same idea. So already does not look a lot nicer. Oh, where'd I lose you, Kelsey? The x's? Okay. All I did, since they're both under the cubed roots, I just simplified. 189 divided by 7 was 27. And then this was x to the 7th, and I had 2 x's here. I just canceled out 2 of them. Simplify. That's all I've done so far, is just simplifying. So from here, is cubed root of 27 perfect? Yeah, that's 3. All right, so something actually was perfect finally. And then x to the 5th, how many groups of 3 can I get out of that? And then how many would be left over? 2. All right, so make sure you simplify first. Okay, simplifying first took this ugly fractional thing into something that wasn't no longer a fraction. Okay, now that doesn't always happen, but a lot of times it will. So do that first, then you can just simplify like normal. All right, take a look at number 2. Again, the 4th root's written over the whole thing. It's okay, it's the same thing if it's split, so it doesn't matter how it's written. But looking at this, can you simplify first? Can you do 243 divided by 3? 81. And again, have I actually used the 4th root? I haven't used it yet, so it's still there. So I have 81. And then my x's, be very careful here. When you simplify your x's, what do you have left? You guys are doing your properties. That's good. So if I cancel out x to the 3rd here, this one turns into x to the 4th. Where is it located? It's on the bottom. It's on the bottom. Yeah, that's probably the easiest thing to mess up. You're like, oh yeah, x to the 4th. You just kind of write it down, not thinking about where it's at. So be careful when you're simplifying. If it's in the bottom, keep it in the bottom. But again, can I write my radical split like that? Is that legal? Yeah, it's legal. All right, so on the top, 4th root of 81. Is that pretty? What is it? 3. On the bottom, 4th root of x to the 4th. It's just x. Yeah, it wasn't bad because they were both perfect. Okay, but again, if you did not simplify that first, ugh, that problem gets really ugly. All right, number 3. Can you simplify first? Yes. Good. 63 divided by 7 is 9. And again, don't forget that radical is still there. I can see a lot of you like simplifying and then like never doing anything with the radical. Okay, can I simplify the x with anything? No. How about the y's? Yeah, this y would cancel. This one would become y squared. So is it still on top? Okay. All right, so that works. So there's no fraction left anymore. Square root of 9. Can I do the square root of x? Square root of y squared? Simplify first. All right, why don't you guys try number 4? All right, so number 4, could you simplify the numbers? 54 divided by 2? 27. My x's, cross off these 2, that's going to make that x cubed. And the y's, turn that to y squared. Is there anything left in the bottom of that fraction? No, it's all gone. All right, how about the square root of 27? Pretty? No. All right, so we'll do our factor tree. I need groups of 2, right? That's just a square root. My index is 2. So I have a pair of 3's that come outside, a 3 back inside. How many groups of 2 can I get from this one? How many left over? How many groups of 2? 1. Left over? None. So 3xy, radical 3x. You got it? Awesome. Oh, really? When I'm crossing stuff out, that's like me counting up. Like if I needed 5 in a group, I'm going to cross off 5, and that number comes outside. Like if I had 5 2's, I'd write down 2 on the outside. Anything not crossed off stays inside. It's like the leftover stuff. Index. Mm-hmm. Because it's just a regular square root, and squared is 2. All right, number 5. 162 divided by 6? 27. How about the x's? It's on the bottom. Good. This x is going to make this one x squared, and it's on the bottom. All right, square root of 27? Okay. We just did that 3 radical 3 on the last one, didn't we? So this is 3 radical 3. Square root of x squared? Just x. Number 6? The fact that the variables don't match, I mean, as far as the numbers, it don't matter. Right, there's no plus or minuses holding it together, so we can separate everything piece by piece. So I can still do the 108 divided by 2. Can I do that? Yeah. So that's still going to give me the cubed root of, that's 54. And then can I simplify the variables at all? No. So the y stays here. That x to the 6 is still on the bottom. Yeah. What? Oh, for the index? No. It's implied. If you want to write it in, you can, but it's not necessary. That's the only one that it's not necessary to write. Cubed root of 54? Good. You would have to do your factor tree. What is that? 9 times 6. That's 3 and 3. 3 and 2. Well, she's right. So it's going to be 3 radical 2. Or 3 cubed root of 2. And then what about the y? How many groups of 3 for the y's can I get out? None. So that y's got to stay in. And I got an awkward space in there now. On the bottom, how many groups of 3 can I get from here? 2. Any left over? No. How's the dividing going? What are you going to do first? Simplify. Yes. All right. Okay. All right. So rationalizing. A simplified answer does not have a radical in the denominator. Let's use the appropriate term there. Not doing my job as a math teacher if you just say bottom. You need to know that's denominator. To eliminate the radical, blank the top and bottom of the fraction by the same radical. You multiply. And remember we multiplied top and bottom by the same thing? The radical used to rationalize should have enough bases to make a blank so that the power and the root cancel each other. Have enough bases to make a...
I want to say numerator. I give up.
Radical used to rationalize should have enough bases to make a blank so that power and root cancel each other. You want to make a power so that the power and the root cancel each other. So like in other words, if it's a 4th root, I want my things to have an exponent of 4. If it's a 5th root, I want an exponent of 5 because you're trying to get those to cancel out. Okay? All right. So number 7, and again, these are starting out that there's no simplifying that can be done from the start. Okay, we're just going to practice the rationalizing part. So looking at number 7, I have a radical 5 in the bottom. This is what we've done in the past. What would you do to get rid of it? Yeah, you would multiply top and bottom by radical 5, right? Right. We've done that in the past. You guys can probably do that with your eyes closed at this point, right? We understand that. But let's kind of talk about that versus cubed roots, fourth roots, fifth roots, and how it's different. What's the index on this? 2. Yeah, you're right. It's an index of 2. Right now, this is 5 to what power? That's to the first. So in other words, we wanted it to have, I needed 2 5s, right, to get the 2 here so that they cancel. So you multiplied 5 to the first by 5 to the first, because 1 and 1 made 2. Therefore, made the same number as this, so it canceled out to be just the 5. Then you just multiply by the top by the same thing and kind of go from there. So if I look at number 8, this right now is 2 to the first, but I need to have, how many more 2's do I need? I need 2 more. So I'm going to have to multiply top and bottom by the cubed root of 2 squared. I always want to make sure that I have the same number. The exponent needs to be totaled up to whatever the index is. They need to be the same. Okay. Now, also that being said, before we finish this problem, this number under here isn't always as nice as you might think. Because I don't want these numbers to get huge, right? When you raise things to exponents, they get big real fast. So you always want to kind of break them down to their most basic. So I want to always try to take something back to like 2 squared or 2 cubed or 2 to the fourth. Like I want to kind of convert them. Like if I had the cubed root of 25 sitting in the bottom, how can you rewrite 25 as something smaller? That would be 5 squared. So I would want to switch something like this to 5 squared, because then how many more 5's is it missing? It's only missing 1 5. Otherwise, if you did it as 25, you'd be missing 2 25's, and 25 times 25 is 625. Your number got big real fast. So you want to take any number that you have under here and kind of rewrite it as to something smaller. That makes sense? It equals the same thing, but it looks smaller. All right, so up here it was just a 2. I can't rewrite a 2. All right, so multiplying here. On the bottom, what will I have? 2. I tried to break it down, right? This gives me 3 2's. Cubed root of 2 cubed is just 2. Kind of broke that down to its most basic. But then on the top, what's 3 times 2 squared? That'd be 12. Yeah, what's 2 squared? Times 3 is 12. There you go. I know, it's a little like, wait, what just happened? Hang with me. We'll do a couple examples to make more sense. All right. Number 9, the 5th root of x squared. So how many more x's do I need? I need 3 more. So I'm going to have to multiply top and bottom by the 5th root of x cubed. I need 3 more of them. So what will I get on the bottom then? Just x. And again, if that is uncomfortable to you, like, wait a minute, what just happened at the bottom? Then multiply them together. Okay, we'll do that. We'll multiply them together. So on the top, that's just going to give me 6 times the 5th root of x cubed. On the bottom, that would give me the 5th root of x squared x cubed is x to the 5th. So then you can see you made that so that this just turns into x. And I still have 6 times the 5th root of x cubed on the top. Okay, you're trying to make the bottom turn into something that the radical will just vanish then. All right, let's try some more. Cubed root of 5 fourths. So first of all, anytime we're looking at these, you do want to see if you can simplify. That was my thing to you, right? With fractions, simplify first. Can you simplify 5 over 4? Can you simplify 5 fourths? No. Okay, that was what I was looking for. But always try to simplify. That makes your life a lot easier. But it does not simplify. Should I split this, you think? Yeah. So I have the cubed root of 5 over the cubed root of 4. All right, can I take the cubed root of 5 or take the cubed root of 4? No. But I can't leave the radical in the bottom. Right now, this is a 4. Can I rewrite that as something smaller? That's 2 squared. So really, how many 2's am I missing then? I'm just missing one more 2. So I'm going to multiply top and bottom by the cubed root of 2. So I was only missing one more 2. So on the top, we get the cubed root of 10. What do we have on the bottom then? It would just be a 2. Can I simplify 10 and 2? This one's under radical, this one's not. I can't touch that. It's not so bad when you actually kind of take those numbers on the bottom and break them down to something smaller, then they're not as bad. Okay, number 11. Can I simplify first? Can I do the 3 and the 9? Can I simplify that? No, one's under radical, one's not. I can't touch that. Can I write 9 as something smaller? That's really 3 squared. So how many 3's am I missing then? I'm just missing one more 3. So the cubed root of 3, we have to multiply top and bottom by the same thing. Yes. All right, let's make sure everybody's okay with what he just talked about right there. On the top, we did 3 times the cubed root of 3. I can't really actually multiply those. The bottom, I did all of that to really just get those 3's to cancel out to just a 3. So then, yeah, these are both on the outside of the radical. I can actually cancel those out. So really all I have left is cubed root of 3. Do I have to have the 1? I'm lazy. If I don't have to write it, I ain't writing it. All right, how about number 12? Anything simplify on number 12? Simplify the fraction at all? No. I don't have x's or y's or z's that are the same to cancel and those numbers to simplify. Okay, so let's go ahead and write this split. So the cubed root of x squared on top, cubed root of 25y squared z. Can I write 25 as something smaller? 5 squared. Right, that's actually 5 squared. All right, so I need 3 of everything, right, to get that to cancel and go away. So I'm going to have to multiply top and bottom by the cubed root of, how many 5's do I need? How many y's do I need? I already have y squared. I'm going to need one more y. And how many z's? That I need 2 of. So I have to multiply top and bottom by 5yz squared. Yeah, you're just going through every piece on the bottom. I make sure you have 3 of all of them. So what does that give me on the bottom then? Yeah, it'd just be 5yz. It's going to break everything down to just this most basic, because you wanted 3 of them to get them to cancel out and be good. What do you got on the top? You have the cubed root of, good. I'm just going to write alphabetically because it drives me crazy if it's not, but you were right. Yeah, just multiplying all together. Can you take the cubed root of any of that stuff under there? Get yours to 3 of anything? No. Can you wait just a couple minutes? Okay. Yeah. All right, guys. Last 2. Okay, last 2. So 13. Can I simplify first? Yes. Make sure. Simplify first. Get that in your heads. So can I do 54 divided by 2? 27. Okay, x's. It would be on the bottom. Good. Don't forget that cubed root still over top of it. I'm fearful that you guys are going to simplify and then totally not write your radicals and be like, yeah, I'm done. Make sure you haven't used those yet. Y squared where? On the top. Questions to there on just simplifying? Okay. All right, so then I have to look at, can I simplify anything? I'm still in the simplify mode. Can I take the cubed root of 27? What's cubed root of 27? That's 3. Can I get a group of 3 y's? No, so that's still going to stay cubed root of y squared. The bottom, can I simplify the cubed root of x? Nope. But I can't leave that on the bottom. So we need to multiply top and bottom by the cubed root of what? X squared. Good, because I need a group of 3. I only have 1 x. I need 2 more. All right, so what do we have on top? Not radical. Cubed root. Okay. X squared, y squared. If you write y squared, x squared, it's not wrong. It just drives me crazy. And just x on the bottom. Can I cancel these x's? No. Under radical, not under radical. You guys seem to be picking this up pretty good. Are we doing all right? You and that word lovely today. Last one on your own. All right. First, what do you always do first? Simplify. So I can't do anything with the numbers, right? It's just 5 over 2. So the 4th root of 5 is still on the top. 4th root 2 still on the bottom. Okay, but I could simplify some x's. It's going to leave me with x squared on the top. And my y's will leave me with just a y on the bottom. So that should have been your first step, just simplifying what you have there. All right, then I want to try to look at, can I simplify anything else? Can I do the 4th root of 5x squared? Anything there? How about 4th root of 2 or y? Okay, but always try, because sometimes there's those perfect numbers sitting inside there like this one was. Okay, so make sure you always check to see if you can simplify any further. Once you're like to the point of I can't simplify anything else, then we want to look at, okay, I can't leave this here. So we're going to have to multiply top and bottom by the 4th root of what? Can you write 2 as something smaller? No, it's still, that's just 2 to the first. And I need groups of 4. So how many 2's do I need still? 3 more. So 2 cubed. I have y to the first. So how many more y's do I need? 3. Y cubed. All right, doing that is going to give me what on the bottom? 2y. Just break that down to its basic. On the top, when I go to multiply this, what's 2 cubed? 8 times 5 is 40. And then I have x squared y cubed. Okay. Can I simplify this now? If I do a factor tree on 40, do I get enough? Do I have a group of 4 of anything? I hear yes, I hear no. If I do a factor tree, that's 4 and 10, 2 and 2, 2 and 5. Did I get 4 of anything? No. Okay, so that doesn't actually simplify. I can't get groups of 4 of either of these. Can I simplify the 2 and the 40? No. So I'm done here. That's all I can do. Definitely something we need to practice.